The graphs of tangent and cotangent functions. The first thing we're going to do is fill out the table on the left, just like we did for the sine and cosine values. So, tangent at negative pi is 0. At negative 3 pi over 4, it's 1. At negative pi over 2, we have negative 1 over 0, so it's undefined. And at negative pi over 4, we have negative 1. So these values come from the coterminal values of 5 pi over 4, 3 pi over 2, and 7 pi over 4. So if you rather find coterminal angles instead of move in a negative direction, then you can do that as well. At 0, tangent is 0. Pi over 4, 1. Pi over 2, 1 over 0. So again, this is undefined. Three pi over 4 is negative 1, pi, 0, and then 5 pi over 4 is 1. So if we go and we plot these values, then we have negative pi 0, 3 pi over 4 is 1, negative pi over 4, negative 1, 0, 0, pi over 4, 1, 3 pi over 4 is negative 1, pi 0, 5 pi over 4 is 1, and we can even keep going and know that 7 pi over 4 and 2 pi. So the way that we curve these graphs, before we make or connect our points, we're going to include our two undefined angles that are in our table. So if it's undefined, it means that we have an asymptote. So I have an asymptote then at negative pi over 2, at pi over 2, from my table, and then I can keep going and know that I have one at 3 pi over 2, and so on. So now when I connect, my tangent function approaches the asymptote. So here we have it. This is our tangent function. So the domain of this function, t, can't be negative pi over 2, pi over 2, 3 pi over 2, and so on. So what that means is for every interval of pi over 2, we have an asymptote. So this is the formal definition if we didn't restrict the domain. So it's pretty much saying from negative pi over 2 to pi over 2, and then from that value to the next pi over 2 interval, which would be 3 pi over 2. So this is the formal definition for all values of n that exist in the interval of all real numbers, which is that z symbol. The range is different than we're used to. Since the graph goes up and down forever, our range is negative infinity to positive infinity. Our asymptotes are every interval of pi over 2, which is related to the domain. So if we say, all right, from negative pi over 2 to pi over 2, that's an interval of pi. So I take k, and we're going to have k be any integer, multiply it by pi, and then add that to pi over 2. And that's our interval for our asymptotes. The period here is different. We're used to the period being 2 pi, but like I said, between each of my asymptotes, I have a period. That's when tangent repeats itself every pi. So the value of my period is pi for the tangent value. And symmetry is odd because it can rotate about the origin. So that's our tangent value. So now let's look at cotangent value. Okay, so our cotangent function at negative pi over 2 is 0, negative pi over 4 is negative 1, 1 over 0, which is undefined, pi over 4, we go 1, 0, negative 1, and 1 over 0, which is undefined as well. Okay, so if I were to plot these values, it would look like this. And then if I kept my asymptotes going, I have an asymptote at negative pi, 0, pi, and 2 pi. So instead of every interval of pi over 2, now it's every interval of pi. So it's a little bit different. So you need to note that the difference between tangent and cotangent right away is that tangent has a point 0, 0. It goes through the origin. And then cotangent has an asymptote at x equals 0. So then if I were to connect these, it would look similar to tangent, but it curves in the opposite direction. Okay, so our domain, again, t can't be negative pi, 0, pi, or 2 pi, right? Like I said, every pi interval. So that's like saying, okay, take an integer n times pi. So that value, 2, 1 more, like the next number of n, so n plus 1, times pi. And that's saying for n that exists in the interval set of integers. Our range is still negative infinity to infinity. The curves just go the other way, but that doesn't affect our range. The asymptotes, similar to our domain, is every value of pi. So you take an integer k and you just multiply by pi, and that's where we're going to have our asymptote for cotangent. The period for cotangent is just like tangent, it's pi. And then this also has odd symmetry because it can rotate about itself around the origin. Okay, so now let's look at vertical stretches and compressions of our tangent and cotangent values. So the first thing we need to do for the first one is identify what's going on. So cotangent t has been compressed vertically. So from all of the other functions that we have graphed before, if you have a value in front of your trig function, so it's in front, 1/4 is in front of cotangent, if it's a number that is greater than 1, it is a stretch, and if it's a number in between 0 and 1, it's a compression. So what does this mean? Well, when we graph, we're only going to go up to 1/4. So I know we're sketching, but I'm going to label these as 1/4 and negative 1/4. Now, remember, the period of cotangent and tangent is pi, so for our intervals, we just take pi and divide by 4. So I'm going to go up to pi, and since we divide it by 4, that means we have a first interval of pi over 4, 2 pi over 4, which is pi over 2, and then we have 3 pi over 4. Now remember, cotangent has an asymptote at 0, okay? And then every pi value, it has an asymptote. So our cotangent value, or function, is going to be in between those two asymptotes. And again, the direction said just one period, so we have just one period and we're going to start at 0. So that means I have a point. So, okay, so now when you think about it, you think cotangent. Okay, well, I know it's going to decrease left to right. So I'm going to start up at pi over 4, 1/4, and then I go down in the middle at pi over 2, 0, and then 3 pi over 4, and then, oops, it's in my dot, but it's right here at pi over 4. So when I connect, since I know it decreases, it looks like this. And then it approaches your asymptote on both sides. Number 2 has negative tangent of t. So what happened to the tangent? It has been reflected vertically. Which means it's been reflected over the x-axis. So nothing else changes. I have my amplitude up at 1 and down at -1. I have an interval of pi. So I have pi over 4, pi over 2, and then 3 pi over 4. And then I have pi. So I know that since it's tangent, I have a value at 0, 0. So I have my value at 0, 0, but then it goes down because it's been reflected. Well, then I also know I have asymptotes at every pi over 2 interval. So that means that this is the one part. Okay, and if I were to continue left, it would look like this. I drew a dashed line so you know that, the solid is just one period. So then I start up at 3 pi over 4, 1, and then I'm back down at pi. So here, and then if I were to continue, it would look like that. But the solid represents one period of the tangent function. Okay, so now we're going to affect the period of our tangent and cotangent values. And again, remember, it's pi over the absolute value of b now. It's not 2 pi, because the period for pi and tangent is pi. It's changed. So if I have 1/2 in front of t, then I have a horizontal stretch. Like I said before, with vertical, if it was greater than 1, it's a stretch. But with horizontal, it's the opposite. So since it's less than 1, which is 1/2, and 1/2 lies in between 0 and 1, therefore it's a horizontal stretch. So if I had a 3 in front of the t, that would be a horizontal compression. So you kind of have to think opposite. Okay, so anytime we have a horizontal shift, you need to identify the period. So I know that the period is going to equal pi over b. And my b value here, looking at my equation, is 1/2. And whenever I divide a number by a fraction, I know that it's going to get bigger. And if I do this, so pi divided by 1/2 is the same thing as pi times 2 over 1. So 2 pi is my new period. Now, that affects my intervals. Lucky for us, we are used to having a period of 2 pi, so we know that each interval is pi over 2. The amplitude didn't change, and since it's tangent, we're going to start at 0, 0, and go up to pi over 2. We have an asymptote at pi. Now, we're used to having an asymptote at pi for cotangent, but you have to understand that the value of your asymptotes are going to change if you change your period. So you need to know that tangent has the characteristic of starting in the origin and increasing and going up. Tangent increases left to right and cotangent decreases left to right. So after you're up at 1, you have to come back down, but before that you have to skip over the next interval and you have an asymptote. So if you know the pattern, you'll know how to graph this if you have a period change. So then if I were to continue this, let's just say, my next interval, it would be up at 1, and then 1 more, you would have an asymptote. Okay, because the whole tangent function is finished. It has those 3 points that it needs. Okay, so for cotangent, what has been done? Okay, so 2 things have been done. We have a vertical stretch, and then since both values are greater than 1, we know that we have 2 opposites. So it's a stretch because the 3 is in front, so we could even say vertical stretch by 3, which tells us that our amplitude equals 3. And then we have a horizontal compression. So since we affected our horizontal axis, we know we're going to have a new period. So the value next to t is 2, so pi over b, which just turns into pi over 2. So that's my period. So this is really compressed. So that means I'm going to have 1, 2, 3, 4 intervals, and over here we have pi over 2. Now, how do I figure out what I'm counting by? Well, you take your period, pi over 2, and you need to chop it up into 4 pieces. So since I'm dealing with fractions, I'm going to multiply by 1/4, which gives me pi over 8. So this is my interval value, meaning the first one's going to be pi over 8. The next one's 2 pi over 8, which simplifies to pi over 4. And the next one's going to be 3 pi over 8. Since it's cotangent, it does not go through the origin, so that's where I have an asymptote at 0. And then I have one period after that, so at pi over 2, I will have another asymptote. So since it's cotangent, I need to, sorry, 1, 2, 3, I have an amplitude of 3 and -3. And since it's cotangent, I start up at 3 for my first interval, so pi over 8, 3, because I know it's going to decrease. Then we go to pi over 4, comma 0, and then we go to 3 pi over 8, comma -3. And so it's going to decrease and look like this, and continue in both directions towards our asymptote. Okay, so for this one, we first have to identify what has been done to it. So 4 is greater than 1, and that's a vertical stretch. And then you have pi over 4. Now, pi over 4 is 3.14 over 4, which is less than 1. It's in between 0 and 1. So that tells you that you have a horizontal stretch as well. So my period changes, and I have my period is pi over that value in front of t, which is pi over 4. So if I rewrote this, I'd have pi times 4 over pi. Well, my 2 pi's cancel, and my period is just 4. So this is how you get whole number intervals. So that means my period is 4, and you take 1/4 of 4, which is 1, so we just count by 1s for all of our intervals. My amplitude is up here at 4, and down here at -4. And it's tangent. So tangent begins at 0, 0, and then goes up, and that's one side, because at the next interval at 2, we have an asymptote. Then tangent comes down, so then we have 3 comma -4, and then it goes back to the middle at 4 comma 0. So if I were to continue in both directions, it would look like this. The last thing we're going to do is look at an equation and write the graphs in form of our a times tangent of bt. So both of these are tangent function. They go through the origin, so we know that. So the first thing we can identify is our period. So if I start at 0, 0, the next time I have that same value is over here at pi over 2. So this is my period. So if I know that my period equals pi over 2, then I need to solve for b to put b back into the equation. So this one's a little simple because we have pi over 2 equal to pi over b, so therefore b just equals 2. It's not always going to be that easy either, but for this one it is. And now we have to solve for our amplitude. Now you can probably see that we have the point pi over 8 comma 3, but it's not always going to be nice and given to you. So we have to say, okay, we know so far we have y equals our amplitude times tangent times 2t. So what we're going to do is we're going to use that point given to solve for a. So our output's 3, our input's pi over 8. So we have y now is 3 equal to a tangent times pi over 8, so you get 2/8 times t. I'm sorry, t is pi over 8, so you have 2 pi over 8. So then, in your calculator, when you solve, what you're going to do, since a is multiplied by tangent, you're going to do 3 divided by tangent of, you can just say pi over 4 if you simplify, and that gives you 3. So your equation for this function is y equals 3 tangent of 2t. Again, yes, you can probably look at the point and identify the amplitude as 3, but it's not always going to be given to you like that. For this next one, it's a little bit hard to see a full period. So it starts to repeat itself, and well, you can see a full period. You have here to here, but what is that value? We don't know. Okay, so what we're going to do is I can identify at pi and say that from negative pi to pi, I have not 1, not 2, but I have a period 3 times. So we're going to use that interval, which from negative pi to pi is 2 pi, and we're going to divide it by 3. So my period equals 2 pi divided by 3. Okay, so then we have 2 pi divided by 3 is equal to pi over b. So we're going to solve for b, multiply it by both sides and get b by itself, and work to get b by itself. So then I have 2 pi over 3 times b equal to pi. I'm going to multiply both sides by 3 over 2, and since I have pi on both sides, those just cancel. So b actually equals 3 over 2. Now we need to use this to solve for our amplitude. So in that formula, we're going to use the point negative pi over 2 comma 2. So we have our output of 2. We don't know our amplitude. Tangent of b, which is 3 over 2, times the input, which was negative pi over 2 from that point. When we multiply, we get negative 3 pi over 4, and you're going to do 2 divided by tangent of negative 3 pi over 4. And when you do that, you solve and you get a equals to 2. So my final equation is y equals 2 tangent of 3 over 2 times t. And our last one, number 7. So we have a period from negative 2 pi to 2 pi. So in this case, our period equals 4 pi. Now to solve for b, we have pi over b, which is equal to 4 pi. If you cross off the pi's, you have 1 over b, which equals to 4. So if you take the reciprocal of both sides, you get b equal to 1/4. So this is our b value. And then if you were to solve for a, you would get 1/2. So our formula is our equation of tangent is 1/2. This one's cotangent, you gotta notice it decreases from left to right, of 1/4 times t, or you could even write t over 1/4, or t over 4.